Okay, and this is a quick tutorial on how to compensate using FlowJo. So let's launch FlowJo. Okay, so here we have our workspace. I'm just going to resize it a little bit. Okay, let's add some samples. So I'm going to add data from the facts caliber because that seems to give people most trouble. I'm going to use Hunter's experiment, import his data, and there we are. So you can see that in the samples have all loaded. So this is the folder where it came from. We also have a folder that's all samples, and then we have a group that's called compensation, which is empty. So FlowJo tries to look for samples that have the word comp in it, and it should see them automatically and automatically put them into the compensation group, but it didn't. So we're going to help it. So we're going to manually select all our compensation controls and drag them into the compensation group. Now we're in the compensation group, and I'm going to start with the unstained beads. Using the left button, double click. And our first default graph is forward scatter and side scatter. So I'm going to draw a quick gate around our bead population. I'm just going to use the auto gate tool and give it a name. Okay, now I'm going to try and let FlowJo do it automatically. So if you go to the compensation button, click on it, it's trying to do it, and it didn't quite. So you see there's a calculation error. I gave it the default name of, the matrix name is compensation, the default color is purple. So let's check the parameters. Fluorescence 1 is CD9 FITSY, so it's grab the correct beads for that. Fluorescence 2 is Notch 1 PE, it's got the right sample for that. Fluorescence 3 is Kit per CP Psi 5.5 conjugate, and it's got the right sample for that. We're not using fluorescence 4, so let's get rid of it. So if you left click on it, and say remove this parameter. Okay, so you can see in the negative column, it is correctly identified the negative beads and put them into our samples. You can see them, they're blue colored here. What it hasn't done, it hasn't found the positives, so we're going to manually help it do that. So in order to do that, if you look here, confirm gates and control assignments look correct. Double click on a graph to edit it. So let's double click on fluorescence 1 to edit it. So I'm just going to use the bisector tool to split the histogram into positives and negatives. So you can see now it's labeled them as CD9 FITSY positive and CD9 FITSY negative. So I'm going to grab the positive population and drop it into the positive column. And you see it's designated. We're going to do that for each parameter. So let's go to FL2. And FL3. So you'll notice in FL3 there's two bright peaks. So what I'm going to do is place the bisector tool here so that the software will take the average of these two means as a bright positive, and that's just fine. Okay, so now you can see that our error has changed into finalized. So now we need to apply this matrix to our samples. So we're going to do it by going to Apply to Group, and I'm going to select the folder here. So now if we go into our folder, you can see that the samples have got a purple matrix next to them, meaning that all of these samples have been compensated. Okay, so let's look at our first sample, wild type unstained. Again, our first graph is forward versus side scatter. I'm not going to gate it. I'm just going to go ahead and look at our compensated parameters. So let's look at compensated 1 versus compensated 2. And I'm going to make another graph and look at compensated 2 versus compensated 3. Okay, so the first thing we notice is the scales look funky. And that is because the FACS caliber is taking our 4-decade log data and it's actually binning it into 1024 bins. And that's why you see it displayed this way. So we're going to correct that. So the way we correct that is we go into the transform function. So that's what the T is here. So if you click on the T, we're going to customize the axis. So if you look under scale, we have linear, log, or bi-exponential. So we're going to stay in log. And the default scaling, as you see, goes from 0.1 to 1024 because of the binning. So we're going to tell it we want to actually go from channel 1 all the way out to channel 10,000. We want to apply to all of our compensated parameters, so I'm going to select them all and then apply. And then it looks like we have our normal looking populations again. Very good. Okay, so I'm going to now apply some gating information. So I'm just going to use quadrants. Based on our unstained control. So you can see that the quadrants have been duplicated here under this one sample. So if I want to apply all these quadrants to all of our samples, I'm going to have to select them and drag them into the entire group. Now all samples have been applied to the same gates. So now if I want to start incrementing through my samples, if I want to increment both graphs simultaneously, I hold down the Shift key while I hit the next sample button. And both graphs update simultaneously. And you can see that the blue triangle here has jumped to this is the sample that we're actually looking at. So this is knockout unstained cells. Increment forward. So this is our triple stained, wild type triple stain. Now let's increment up to our knockout triple stains. So you can see there is a bit of a difference here in the notch versus kit graph. So if we go backwards, you can see it's a subtle change, but it is a change. Okay, so just for a second, I'm going to increment forward. We're going to go look at so this is our FTSE control beat that we use for compensating. And if you look at this, it doesn't look like it was compensated very well. So what I'm going to do to convince you that it was compensated is we're going to go into well actually, if you notice here, you see how the data has been kind of divided up. That's called picket fencing, and that's because of the binning that the caliber has done. So to overcome this, We're going to go back into the Customize Axis. Now we're going to go into by exponential. And in by exponential, we're adding negative values below the 0 in the log scale. And I'm going to increase our width basis to give us a bit more leeway. And again, I'm going to apply this to all of our samples. Okay. So in the by X, the quadrants aren't quite working for us. But what it is showing us is what the compensation has done is it has found the mean of our negative population and adjusted the compensation so that the mean of our fluorescent FTSE positive only is the same value. You can see that it's going right through this line. So that shows that it is perfectly compensated. And we can do that for each of our control samples. So you can see that the PE is correctly compensated on PE and per CP, and likewise with everybody else. Okay, so that's just to convince you that the compensation was actually correct. But if we keep it in the by exponential, your data is going to look kind of funny, especially when we're looking at the unstained controls. So once you've been convinced that the compensation is correct, we can go back to the regular logarithmic scaling. But before I go, I want to show you how to edit the compensation matrix if you want to. So let's go back to our FTSE bead. So if we want to edit the matrix, we can either point to it and double click, or we can go to the Tools, Cytometry, Edit Compensation Matrix. So that's the matrix we want to edit. So before we can do anything, we have to tell it that we want to edit it. So once we've done that, it automatically made a copy. So it's a compensation copy. And we've automatically changed all of our compensations to the copy. So if we did nothing now, it would be exactly the same as our original compensation. So if we want to start editing, so let's look at the FTSE bead right now. So it is calculated that it took 30% of compensation it took 30% of subtracting fluorescence 1 for fluorescence 2 to make it look correct. So if you didn't like that, for example, let's change that. Let's put in 20%. So you see what happens. This population moved dramatically up. So this is undercompensated. And to show it even further, that is grossly undercompensated. So let's bring it back to the 30%. And to show you what that's overcompensated. Still overcompensated. Still overcompensated. So the point is we want to make this group exactly parallel with the unstained group. Something like that. So that shows you how you can edit. So once you've edited it and you're done with it and you like it, the edited compensation has already been applied to your samples, as you can tell by the blue matrix now. Okay, so that, in a nutshell, is compensation on FlowJo. So let's go back to our unstained cells, and we'll go ahead and turn our axis back to regular logarithmic. Now that we're convinced that the compensation was actually correct. And now our samples look like they should. Ta-da! Okay, so that is compensation on FlowJo. Thank you.